Hello everyone. Today I am going to discuss a topic on probability theory and stochastic process. My topic is autocorrelation function. The autocorrelation of a random process x of t measures the degree of similarity between two values of the process at two different time instants t1 and t2. Let x1 equal to x of t1 and x2 equals to x of t2. The autocorrelation function is defined as Rx of tau is equals to expectation of x of t1 into x of t2, that is equal to expectation of x1 comma x2. Now we are going to discuss some of the properties of autocorrelation function. Property 1. The mean square value of x of t is expectation of x square of t is equals to Rx of 0. It is equals to the power of the process. Proof. We know that for x of t or x of tau equals to expectation of x of t into x of t plus tau. If tau equals to 0, then Rx of 0 is equal to expectation of x of t into x of t, that is equals to x of x square of t. Property 2. The autocorrelation function is maximum at the origin, that is Rx of tau mod Rx of tau less than or equal to Rx of 0. Now we will prove that. Proof. Consider two random variables x of t1 and x of t2 of x of t. Define the time values t1 and t2 respectively. Now take a positive quantity, that is x of t1 plus or minus x of t2 whole square less greater than or equals to 0. Take the expected value. Now keep expectation x a of x of t1 plus or minus x of t2 whole square greater than or equals to 0. Now expanding squares. If we expand the squares, then expectation of x square of t1 plus x square of t2 plus or minus 2 into x of t1 into x of t2 less than or greater than or equals to 0. Simplify using the linearity of expectation. That is expectation of x square of t1 plus expectation of x square of t2 plus or minus expectation of x of t1 into x of t2 greater than or equals to 0. From the earlier result, that is from the property 1, expectation of x of t is equals to Rx of 0. By substituting Rx of 0, we get Rx of 0 plus Rx of 0 plus or minus 2 into Rx of t1 comma t2 greater than or equals to 0. Given that x of t is a Whitson stationary and tau equal to t2 minus t1, then 2 into Rx of 0 plus or minus 2 into Rx of tau greater than or equals to 0. Now if we divide by 2, then Rx of 0 plus or minus Rx of tau greater than or equals to 0. This gives two inequalities, that is Rx of 0 greater than or equal to Rx of tau. First one, and the second one is Rx of 0 greater than or equals to minus Rx of tau. If we combine that, we get R mod Rx of tau less than or equal to Rx of 0. Now I am going to discuss property number 3. Property number 3. Rx of tau is an even function of tau. That is Rx of minus t is equal to Rx of minus tau is equal to Rx of tau. Proof. We know that Rx of tau is equal to expectation of x of t into x of t plus tau. Let tau equals to minus tau. Then if we substitute minus tau in place of tau, then we get Rx of minus tau is equal to expectation of x of t into x of t minus tau. And if we if we also assume u equal to t minus tau and t is equal to u plus tau. Then if we substitute those two values, then we get Rx of minus tau is equals to expectation of x into u of tau into x of u. Then Rx of minus tau is equal to expectation of x of u into x of u plus tau, or Rx of minus tau is equal to Rx of tau. That is property number 3. Property number 4. If a random process x of t has a non-zero mean value, that is expectation of x of t not equals to 0 and ergodic with no periodic components, then limit tau tends to infinity, rxx of tau is equal to x bar whole square. If we need to prove that, consider a random process x of t with random variables x of t1 and x of t2. Given the mean value is expectation of x of t is equals to x bar not equals to 0. Then the autocorrelation function is rxx of tau equal to expectation of x of t into x of t plus tau, that equals to expectation of x of t1 into x of t2. Since the process has no periodic component, as tau tends to infinity, the random variables are independent. That is, limit tau tends to infinity, rxx of tau is equal to expectation of x of t1 into expectation of x of t2. Since x of t is ergodic, then expectation of x of t is equal to x of t2 is equal to x bar. Therefore, limit tau tends to infinity, rxx of tau is equals to x bar square. Hence proved. Property number 5. If x of t is periodic, then its autocorrelation function is also periodic. We need to prove that proof. Consider a random process x of t which is periodic with period t naught. Then x of t is equal to x of t plus or minus tau, or x of t plus tau is equal to x of t plus tau plus or minus t naught. Now we have rxx of tau is equal to expectation of x of t into x of t plus tau. Then rxx of tau plus or minus tau naught is equals to expectation of x of t into x of t plus tau plus or minus t naught. Then given x of t is a Whiteson stationary, then rxx of tau plus or minus tau naught equal to expectation of x of t into x of t plus tau. Rxx of tau plus or minus tau naught equal to rxx of tau. Therefore, rxx of tau is a periodic. Property number 6. If x of t is ergodic, has zero mean and no periodic component, then limit tau tends to infinity, rxx of tau equals to 0. Proof. Limit tau tends to infinity, rxx of tau is equal to x bar square, where x bar is a mean value of x of t. If x bar is equal to 0, then limit tau tends to infinity, rxx of tau is equal to 0. Property number 7. The autocorrelation function of a random process rxx of tau cannot have any arbitrary shape. Proof. The autocorrelation function rxx of tau is an even function of tau and has a maximum value at the origin from property 2. Rxx of tau is also related to the power density spectrum through Fourier transform. The form of the spectrum is not an arbitrary. Hence, the autocorrelation function also cannot have any arbitrary shape. Property number 8. If a random process x of t with zero mean has a DC component A, as y of t is equal to A plus x of t, then rxx of tau equals to A square plus rxx of tau. We need to prove that. First of all, given a random process y of t is equal to A plus x of t, then now Ryy of tau is equal to, from the autocorrelation function, expectation of y of t into y of t plus tau, that is equals to expectation of A plus x of t. From y of t is from equation 1, y of t equal to A plus x of t. We substitute that A plus x of t into A plus x of t plus tau. Then expectation, if we multiply both within the brackets, then we get expectation of a square plus ax of t plus ax of t plus tau plus x of t plus x of t plus tau. Then expectation of a square plus a into expectation of x of t plus a into expectation of x of t plus tau plus expectation of x of t into x of t plus tau. Then expectation of a square is equals to 0. Expectation of a constant is always 0. So 0 plus 0. X of t into x of t plus tau is a autocorrelation function, that is Rxx of tau. So Ry of tau is equals to a square plus Rxx of tau. Hence proved. Property number 9. If a random process z of t is a sum of two random process x of t and y of t, that is z of t is equal to x of t plus y of t, then Rzz of tau is equal to Rxx of tau plus Rxy of tau plus Ryx of tau and Ryy of tau. We need to prove that given z of t is equal to x of t plus y of t, then Rzz of tau is equals to expectation of z of t plus z of t plus tau, that is from autocorrelation function expectation of x of t plus y of t into x of t plus tau plus y of t plus tau, that is from the above equation. Then Rz of tau is equal to expectation of x of t into x of t plus tau plus x of t into y of t plus tau plus y of t into x of t plus tau plus y of t into y of t plus tau. If we multiply all the terms within the bracket, we get that equation. By applying expectation to each and everything, then we get expectation of x of t into x of t plus tau plus expectation of x of t into y of t plus tau plus expectation of y of t into x of t plus tau plus expectation of y of t into y of t plus tau. Then if we observe that x of t into x of t plus tau is an autocorrelation function for Rxx of tau, x of t into y of t plus tau is an autocorrelation function for x Rxy of tau, and y of t into x of t plus tau is an autocorrelation function for y comma y and x. Y of t into y of t plus tau is autocorrelation function for y of tau. So if we simplify that, Rz of tau is equal to Rxx of tau plus Rxy of tau plus Ryx of tau plus Ryy of tau. Hence proved. Thank you.